Students, this is a continuation video in a block elements. We will learn today the tricks for the electronic configuration of actinide elements. Okay, let's start. Okay, welcome back student. In our chemistry class, this is actually a continuation video from a block elements for the tricks of the electronic configuration of the a block elements. Now we have already done the lanthanide portion, since this is our general formula of the outermost electronic configuration for the A block elements, as since we have already known that if we put n equals to 6 and starting from xenon configuration, then 4f1 to 14 5d 0 to 1 and 6s2, this is our lanthanoid elements. We have already done it for you in the previous video. And if putting n equals to 7 and then starting from radon, then we'll get 5f1 to 14, 6d 0 to 1 and then 7s2. So this is our actinoids. Now today we are going to find out the electronic configuration of the actinide compounds. Okay. Now the actinide compounds, there are 15 compounds mainly. Let's start with the compounds. Say for example, actinides, first is actinium. Okay, actinium has the atomic number of 89, and then it comes thorium. This is how we can write. Actinium actually gives us first radon, and then actinium has no F electrons, so if we put over here 4f 5d and 5f 6d and 7s in place of actinium, then we are going to get 5f is 0 and 7 is always 2, because s always fill up with 2 electrons. And since radon, as you already know, since you know that radon has got the 86 atomic number, so there will be only 1 d electrons left to complete this system. Okay, now today we are going to start the proceedings of the electronic configuration of actinoids. Okay, so now I have already written all the elements starting from actinium to lawrencium and filled up with 5f 60 and 7s electrons. Now for all the s electrons you can put 2 over here. For all the s electrons, and 2 you can easily put 2 over here, there is no problem. Okay, now the trick is over here. See, this is the trick. Okay, starting from actinium we can start it to get as 0. No 1 electron will come in case of F, and no 5 and no 8. So starting from actinium and then comes thorium. Thorium, no 1 electron will come, so this F will also be going to be 0. Okay, this F is going to be 0. And now the next part that comes 2 for 2. Okay, now 7 for 7 and 14 for 14 is already, I have already done it for you. 7 for 7 means starting from 0, 1, 2, 3, 4, 5, 6, 7, 8. That means the 8th electron, 1, 2, 3, 4, 5, 6, 7 and 8. That is curium. Curium, the number of electrons in curium should be 7. And the last one is the 14th electron, that lawrencium should have also 14 electron. Okay, that I have already marked it for you for the calculation portion. Now the next is protoactinium, and protoactinium, for protoactinium it should be 2 and then 3 and 4. So there is 2 electrons in F, 2, 3 and then 4, and 5 is not going to come up to neptunium, you can see its F is 4. Now 5 is not going to come, so for plutonium there will be 6 electrons, and then for americium there will be 7 electrons. Okay, now from here already curium is 7 electrons, so for berkelium 8 is barred, 8 is not going to come. So for berkelium you can see it is 9, and then starting from here, since berkelium is 9, now you can write 10, 11, 12, 13 and 14. From californium to nobelium there will be no problem in the F electrons. So up to this point the F electron configuration already done. Now remaining part is d electrons. Okay, now d electron calculation is very easy. So say for example you take Einsteinium from here. Einsteinium has got total 99 number of electrons, and radon has got 86 F electrons. It has got 11 F electrons, and say for example d electrons is X is the number of electrons in d, and 2 S electrons over here. So if we calculate it for X, then we can get 99 minus 6. So X is 0. So for Einsteinium D is 0. Okay, this is how if we calculate all this portion we can calculate the number of d electrons. Okay, I am calculating it for you. So okay, now I have already filled up all the d electrons for you. Now you can see starting from actinium to lawrencium, so all the d electrons are completed. Okay, so now let's say for I have taken the so say for neptunium has got 93 electrons, neptunium, and it has got 86 electrons for radon, plus 4 electrons in F, and X plus 2 electrons in the S. Now if we calculate X equals to 93 minus 1992, so X equals to 1. So for neptunium that you can see 60 portion d electrons has come only 1 electron. So students, this is how, if we know the trick over here, that you have to understand, this is the basic trick. Okay, so easily we can get the general formula of electronic configuration of actinide elements. Okay students, so up to this point it should be clear to you. Okay, please subscribe my channel, and to get more information on the chemistry, please like my channel. Okay, thank you.